Hi everyone, Mr. Markwick here. In today's video, I'm going to be going through the solutions for question 3 of the 2024 SACE Stage 2 General Mathematics exam. You can see it's a question on the critical path method. It says here, Peter is considering selling her house and moving to a larger home to accommodate her growing family. The network diagram below shows a series of tasks that needs to be completed for this to happen. Explain why the dummy link marked X is required in the network diagram. Now, this is the dummy link we're talking about here. Dummy links are usually represented by a dotted or dashed line. Now, this is not task X. The dummy link is a continuation of task C, and it is showing, obviously, that task C is a prerequisite for tasks G and F. Task C is also a prerequisite for task E. However, tasks G and F also need task D to be completed before they can start. So task D is a prerequisite for G and F. However, task E only requires task C to be completed. So task D is not a prerequisite of task E. That's why we need that dummy link in the network. Now, this question's worth 2 marks. So you need to sort of provide all that information as succinctly as possible. So I guess the first thing, let's talk about tasks G and F. So tasks G and F require tasks C and D to be completed before they can start. Or you could say, tasks C and D are prerequisites of tasks, or both tasks G and F. However, task E only requires task C to be completed before it can start. Or you might write, for example, task C is the only prerequisite of task E, for example. Okay, there's your 2 marks. Moving on to the next part of the question, it says the following precedence table has been completed for the above network diagram. This precedence table has obviously the task, the prerequisite for each of those tasks, the time it takes to complete each task, the earliest starting time, and the latest starting time. Now, the easiest way to identify the critical tasks using something like this is to look at the earliest starting time and latest starting time columns, and the tasks that have the same earliest starting time and latest starting time are on the critical path, or are what to be said as critical tasks. So, for example, task A is a critical task because the earliest starting time and latest starting time are the same. Task B is not going to be on the critical path because those values are different. Task C is going to be a critical task. Task E is going to be a critical task. Task H is going to be a critical task, as is task J. They're all the tasks, if you're looking at these last 2 columns, that have the same values. Okay, so they're said to be critical tasks. That's not actually the question though, but that will come in handy shortly. It says here the network diagram shown above should contain 2 dummy links. Use the information from the precedence table, draw that second dummy link on the network diagram above. Now, when we were looking previously at that dummy link that they gave us, this one here, X, you can see that it was a continuation of task C. Now, if I look at the table, task C appeared here by itself, but then appeared with task D for 2 other tasks. So that's kind of what we're looking for to work out where that other dummy link will be. Task G is by itself here, but then appears with task H here. So the dummy link is going to represent task G, and it is going to show that task J needs tasks G and H, but task K only needs task G. So that extra dummy link is going to be, as I said, a continuation of task G to the beginning of task J. It is worth, this question, 2 marks. So you do need to show an arrow there to show that it's a directed arrow. It is a directed network, so the arrow is required, I should say. All right, Next part of the question, I'm going to keep it zoomed out here because you kind of need to be able to look at this precedence table when we're answering this question. It says, using the information from the precedence table and the network diagram, identify the statements that are correct. Place a tick in the boxes next to all correct statements. So this is worth 2. So that's a bit of a clue that there are actually 2 correct statements. So let's look at the first one, or we'll go through them one at a time. Task H is on a critical path. Well, we've highlighted task H here. It has the same earliest starting time and latest starting time. So it is a correct statement. The second statement there says a delay in the completion of task D will always cause a delay in the starting of task F. Now, not necessarily. If it's not on the critical path, this won't be a correct statement. Task D is not on the critical path. In fact, you could delay task D for up to 2 days and it wouldn't impact or delay the starting of task F, so that's an incorrect statement. The third statement there says task F has 2 days of slack time, so looking at task F, the latest starting time is 10 days, the earliest starting time is 9 days, so the slack time there is only 1 day, so not 2 days. That is an incorrect statement. The fourth statement there says a delay in the completion of task E will increase the minimum completion time for the network. So let's look at task E, and that will be a true statement if it's on the critical path, which it is, so we'll tick that one. The last part of this question says to state the critical path and the minimum completion time. So it's worth 2 marks here, so 1 mark for the critical path and 1 mark for the minimum completion time. Now, I've already highlighted those critical tasks, so it's simply a matter of just listing them here. It's A, C, E, H, and J. And the minimum completion time is simply adding the time to complete each of those tasks. So it's 5 plus 4 plus 2 plus 3 plus 3, okay, which will give us 17 days. So 17 days is the minimum completion time. This is your critical path, A, C, E, H, J. Hopefully that video makes sense. Hopefully it helped, and thanks for watching.